So you heard about the accelerator trials a little bit before in the previous session, so I'm just going to define what they are in a bit more detail. So basically what they are is a series of large-scale trials where we've set them up in different locations around New Zealand where we're in places where we know the trees should be doing better. There's something not quite right. There's some sort of gap in their productivity, and some of that's based on the work that Dean's done with the productivity gap analysis. But in other places, we've talked with the landowners, with the forest managers. They know there's something wrong. There's something out of balance there. But the key thing about these sites is they're also representative. All the effort we can put into these particular sites, we can extrapolate that out into large parts of the estates around that location, but also in other parts of New Zealand as well. And a key thing around these trials is that they've been facilitated by incredible support from the industry. People from the industry have been involved with finding the locations, determining what the treatments should be, and this is an ongoing process. So we're really grateful for the support we've had to get these guys up and running because they are large. So what is different around the accelerated trials? Well, in a standard trial, you might have different genotypes that you're looking at, plus minus fertiliser at a couple of different rates. But we're really pushing the boat out here. We're sort of looking at what's the impact if we add in novel products, novel stimulants. What happens if we alter the nursery management of the stock coming into the site? What happens if we change site preparation, if we go in and do large-scale modifications at the site, or in some cases, if we don't do any modification to the site for plant prep. We're also looking at the microbes intensively at the site as well. And we're also bringing in silvicultural variations, how we stock the site, how we might thin the site as well through time. We're building in issues around what the climate is now and what the climate could be. And at the same time, we're bringing in all this monitoring capability, which you heard about in the previous session, to really understand what the trees are doing and how that can guide what we do next at these sites. Now, it might look like we're just going to basically take literally everything and throw it at these trees, but we do have a bit more of a strategy, and it goes all the way back to the reason for the GCFF existing, to look at the crop and figure out at this moment in time what is the best thing we can do to enhance the productivity of the site. And the power that the accelerated trial gives us, because it's got all of these elements, we can do really interesting things. At a given site, we've got clone A and clone B. Clone A is outperforming clone B. It handles the stresses and the pressures at the site better. But let's say we introduce an intervention. Well, all of a sudden we realise that clone A does not respond to that intervention at all, but clone B, it does respond to that intervention. So all of a sudden, clone B plus intervention is actually the best thing we could be doing at this site. And that's what this integrated framework gives us, the power to look at different responses and how they interact. And because we're doing all these things and we're applying all this monitoring technology to the accelerator trials, we can go further. We can look at genetics by site, by management, by microbes. We can understand these interactions and we can find ways to make the best use of them. An example of some of the things that we're doing, we're not going to be covering all of the things we're doing in the accelerator and trial in detail, so I'll just pick up a couple of areas. So one of the things the accelerator trial supported is further nursery research. Back in 2013, when we started the GCFF program, we had exactly one nursery outplanting study. It showed us some really interesting results. So under the GCFF, we were able to replicate it in 5 other sites around New Zealand with bulky trials, and at the same time put in another 40 smaller trials all around New Zealand. So this is producing significant legacy effects in how that forest performs based on what they happen in the nursery. But we're also seeing the ability to actually customise nursery management to the site so that we can prepare the trees for what they're going to face in the forest. And again, this research has been facilitated by great support from the industry, but also Tenai Nursery and Arbigen as well. Here we've got an example of some of the technology we're deploying. So this is a plot showing variation in electrical conductivity of the soil, and this was produced by using a tool called a dual EM. And basically it gives you soil information without having to dig holes. You can move this device over the soil and it tells you things about the properties. Now, the interesting thing about this site is it was a pasture we afforested. This is one of the accelerator trials. If you looked at this above ground, it just looks the same. You wouldn't have picked that there's all this variation. And some of these variations come from things that maybe happened 60 years ago, 70 years ago, but they're still impacting the site. And why this matters is that if we look at the early productivity of the trees that were planted on top of that area, we can see that there are some clones or some stock types that really respond to electrical conductivity. The higher it is, the worse they perform. Whereas there are some stock, they don't really care. They're about the same regardless. So it can help understand why productivity is what it is and why some stock is better suited to other areas. So overall, we're trying to bring a lot of different domains of science together to stack up our productivity gains. If you sort of look at this plot as for a given site, you've got an optimum yield and you're trying to get as close to that as possible. So we can see that we can start getting close to that by understanding the site. By bringing in the right silviculture, we can get even closer. By working with the soil microbes and getting them on your side, you can get even closer to that target. And then perhaps by some new products to further encourage stimulation and to get the trees as healthy as we can actually get close or even achieve that target of the best possible growth we could get. Now, this is an absolutely challenging approach. There's lots of different science to put together. It's a long-term trial. And we're a few years into it, but we're already seeing some really significant and positive results from this approach. So to start off with, we're going to talk about the value of understanding the site and what it can deliver.